All right, go ahead and grab your water notes. Make sure you're writing on those notes and highlighting as you go through so that you're really paying attention and learning. Okay, so today, this video is all about water. And the first thing on the notes, it says that water makes up 70 to 95% of our bodies. That's crazy. We're mostly water. And it's also 70 to 95% of the earth, too. So there's lots and lots of water on the earth. So in all the oceans and rivers and things like that. Okay, so water is a polar molecule. Polar molecule. And what that means is that it has a positive side and a negative side. So you can tell right there those the oxygen, one oxygen, is negative, and the hydrogens are positive. So the word polar means it has two different charges, a negative charge and a positive charge. So it says oxygen, slightly negative, and that's because it has more electrons than it does protons. And then hydrogen is slightly positive because it has a proton, more protons than electrons. So because of its polarity on C, because the water is polar, water makes hydrogen bonds. So when water bonds to water, it makes a hydrogen bond. So here you can see water. Let's change, oh no, blue's not, purple. Okay, so here's water, 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 water. So there's 5 water molecules here. And then if you look where the yellow is, it's a hydrogen bond. So a hydrogen bond is where a water molecule bonds to a water molecule. Now, don't be confused. I don't want you to think that where oxygen and hydrogen bond right there inside the water, that's not a hydrogen bond. Where water molecules bond to water molecules, that is a hydrogen bond. This bond right here is actually a covalent bond. Y'all remember what covalent bond means? It's where the electrons are shared. Good. So water bonds to water with a hydrogen bond. So that's the most important thing you want to know about water is that it has hydrogen bonds. When water bonds to water, it makes hydrogen bonds. The polarity makes it possible to conduct electricity, and that's why wet substances are much more likely to get electrocuted. When it's lightning outside, you have to get out of the water because you're much more likely to get hurt in the water because those hydrogen bonds conduct electricity. So electricity flows through water really well. And then the polarity allows for a single water molecule to bind to 4 other water molecules at a time. And that's what you see here, the 4 at a time. So because of the hydrogen bonds, it bonds to each other, it has electricity, and it can bond to 4 at a time. Okay, so the word cohesion, hey, guess what? It's because of the hydrogen bonds that it does cohesion. But this is where water binds to water. And I'm actually going to draw it for you. This picture is good, but I want to draw it to you. Okay, so you have a hydrogen, and an oxygen. That's what water looks like at liquid state. Okay, so so I'm going to make this a different color. Another hydrogen, oxygen, right there. And so these molecules, water binds to water right there, that bright yellow, that is a hydrogen bond. So water bonds to water with hydrogen bonds. It says this term refers to the water molecule binding to other water molecules. It's important if you think about, when it rains, water gets in the soil, and then water is sucked up a tree, and that doesn't require any energy to do that. So in order for water to get up a tree, and you can see the tree on the left side, it's got to go up these little pipes that are inside the tree, and those little pipes are called xylem, if you want to add that word, Xylem. That's the name of the pipe inside the tree. And water flows up that pipe with no energy. Coolest thing ever. It goes up 100-foot tree. Don't require any energy, but it's because the water molecules stick to water molecules. Okay, opposite. Water molecules stick to other things, not water. Water to water is cohesion. Water to something else is called adhesion. And guess why it can do that? Because of the hydrogen bonds. So if you look at this picture, water is binding to salt, which is sodium chloride. And then the question says, which atoms of water are attracted to the sodium? So look at the picture and you can tell. And then how about the chlorine? Okay, so if you look at the picture, if you go back, you can see the oxygen is red. So the water binds to the sodium. Can y'all see how that's a little water molecule and it's binding to sodium? And then the sodium is binding to the chlorine also. So water binds to sodium and to chloride, and that's called adhesion. So cohesion is water to water, adhesion is water to something else. Okay, these are all properties of water. So cohesion was like the first property. Adhesion was the second property. Third property we're talking about is surface tension. And this is how, you know how sometimes you're in the water, like in fresh water, not a pool, but in fresh water, and you can see a little bug walking on top of the water? Well, it's because of cohesion. The water molecules stick together, and the bug is so light it can walk on top of the water because water creates a surface tension. So it says this is the linking together of water molecules because of hydrogen bonds. Everything so far, 1, 2, and 3, because of hydrogen bonds. Because of hydrogen bonds. Okay, water helps with temperature regulation. So a lot of the sunlight, I want to say I've read it before, it's like 70% of sunlight comes in and it hits the water. So most of the sunlight is hitting the water, and the water stores that heat and then releases it at night. And so the water actually helps keep the earth warm. So it says water is the only substance on earth to be found in all 3 states naturally, like ice, and then liquid, and then evaporation gas. Water can act as a huge piggy bank. So that's what I was saying on in B. It says when the sunlight hits the ocean and other water bodies and the water heats up slowly, it absorbs sunlight energy. So the water stores the heat. This property is made possible because of, guess what? You named it, hydrogen bonds. Remember, if you look at this picture, no, not that picture. If you look at this picture, so there's those 4 hydrogen bonds. So when sunlight comes in, it's trying to break those 4 hydrogen bonds. On D, it says it takes a tremendous amount of energy to break all those hydrogen bonds. Well, that's important. If you ever swim in a river, down deep in the river, it's cold. And on the top of the water, it's warmer. Well, that's good because the water maintains a stable temperature. So water doesn't change temperatures a lot. And the reason is because of these 4 hydrogen bonds. But that's really good that it doesn't change temperatures for the fish. Fish can't, how in the mornings it'll be 60 degrees and then in the afternoons it'll be 80 degrees. Well, that wouldn't be okay for a fish. A fish would die if that happened. Okay, so there it is in all 3 states, liquid, gas, and water. Okay, so all 4 hydrogen bonds have to break at the same time to allow water to actually evaporate. That's why, boiling water is so hot. It has to get that hot for it to evaporate. It requires a lot of energy. Okay, so total amount of kinetic energy in a substance is heat. There is so much energy moving through the metal that it glows. So that's just showing like on a stove with coils. Lots of energy there. Okay, so on D, we said it takes tremendous amount of energy to break all the bonds. It is important because it helps keep, okay, so you want to, on E, make sure you highlight, keep the temperature of Earth stable. So because of the water absorbing sunlight, the water helps keep the temperature stable. Okay, so heat, on down to, you say kinetic energy, and then heat is the measurement, is the total amount of kinetic energy in a substance. Temperature is the measurement in the intensity. So this is looking pretty intense being red, right? Okay, and then ice cubes and cold drinks. So as hydrogen bonds, and there's temperature. Okay, so ice versus water. Look at the hydrogen bonds. That's the difference. Liquid, the hydrogen bonds are like at 90-degree angles. And then ice, see how the water's more spread out? The water spreads out as it freezes. And that's why, like, if you ever put a canned drink in the freezer, it's going to burst because the ice spreads out. So something with ice is going to get bigger. Okay, so where it says ice cubes and cold drinks, the hot drink molecules lose energy as they try to warm up. And it says the frozen water. Okay, so next thing, we got 2 more things and we're done. Evaporative cooling, that's just where you sweat and it pulls the heat out. So water has that ability to pull heat out of your body. It says putting heat energy into water, so causing the water to evaporate and carry heat energy away from the body, thus providing a cooling mechanism. So just like when you sweat, it cools you off. Well, water is actually, what it's doing is it's taking heat from your body. Wind increases the effect of cooling by carrying the water vapor from the body. And then humidity is water vapor in the air. So water has evaporative cooling too. So that's one of its properties. It can cool you off. Okay, and then we actually already said this with G, but water expands as it freezes. So water condenses down to 4 degrees Celsius. After that, the colder it gets, the more it expands. So it just spreads out. The water molecules spread out, and that's what makes frozen things swell or burst, like a can or something like that. All right, I hope this was helpful.